The Diels-Alder reaction is stereospecific. What that means is that if you have substituents on the same side of the diene or dienophile, they will be cis on the newly formed ring. So what does that mean? So let's actually take a look at the reaction. So as always, the reaction would proceed this way, like that. So if you pay attention here, these two groups right here they in the newly formed ring, they will be cis to each other. So they will be on the same side. So the way to show that is you can use a solid wedge. Just like that. So they are cis. So this is cis. They are on the same side. And the reason why is because there's an H. So they are on the same side. I think you can see that this is cis to begin with. So they should be on the same side. Same thing here. So these two groups right here are on the same side. Or you can say they're outside. And of course they have H's. Those H's are, well, actually let's keep the H's for later so that we don't show them. It's a really quick way. So it goes this way, they shift, and then they, okay, so let's draw the product. Okay, I need to redo this. There's a double bond right there. There's also a double bond right there from the alkyne. And then you would have these two on the same side. Okay, not sure what happened here. So CO2, CH3, CO2, CH3. And then you would like I said, to have the methyl groups on the same side. So in this case, you would again put a wedge, a solid wedge for the methyl. So put them on the same side. If they're outside, just put them on the same side. The endo rule. So we're going to take a look at this important rule. It's going to apply in the following examples. So if we were to go ahead and react these two, the diene and the dienophile, again, attack is there, and that's there. Again, you can draw a line in between. Remember, we're going to form a bicyclic bridge. So it's going to be like this. Okay, so when you get to this point, you have a choice. So this group right here, the aldehyde group, formal group, is either going to be up or down. So endo would be this way. This is endo, pointing down, and exo would be pointing up in the following fashion. The rule says that the preferred product is the endo and not the exo. So you need to draw, when you get to examples like these, you need to draw the endo where the group, in this case, the electron withdrawing group, is pointing down, not up, or in this equatorial position, if you recall these. And plus, remember, this comes with also an enantiomer. Now, you don't have to draw the enantiomer, but you just need to remember that there's an enantiomer, which is a mirror image of that. Why is it preferred? It's quite complicated, but I can give you a little bit of an explanation here, is that there's an overlap of the p orbitals in the electron withdrawing groups, with the p orbitals on C2 and C3 of the diene. So talking about C2 and C3 of the diene, in the diene, if you take a look there, that actually stabilizes the transition state. So that's all we can say about this as of right now. There's no need for you to give me an explanation. Just be able to draw your product using the endo group, using the endo product.